All right. Hey, everyone. Welcome to our first of many videos on data visualization. So we started the class getting introduced to R. We've worked through some data manipulation and wrangling, and now we're moving to the data visualization portion of the class, which we'll start with in this video. And the goals of this video are just to introduce you to the package that we'll be using, which is called ggplot2, which is a part of the tidyverse library that we've been loading in every class, and to introduce you to ggplot by way of scatter plots and box plots. So we can go ahead and get started. So I'm going to start by loading in the tidyverse through this library function, and then tidyverse that way. And just as a reminder, so usually when you load in the tidyverse, you get a few notices down in your console. And we went over these one of the first times we introduced the tidyverse, but we can revisit that the multiple packages that tidyverse loads in include some of the ones we've been using maybe unknowingly before, but the first one on the list is this ggplot2 package. And so that's just to cue you in as to the tidyverse is loading in lots of packages. One of them is ggplot2, and that's going to be our main package for today. And we're going to be working with our surveys data frame, as we have now gotten pretty used to loading in. So we can create an object called surveys and assign it using our read_CSV function and call in quotation marks, our data/porta data joined CSV. And I'm going to do one more thing here, which is pipe to filter this just a little bit. We talk in class a lot about identifying NAs and knowing where they are. And while sometimes it's really important to keep your NAs in your data frames, just for the sake of learning about visualization right now, we're going to remove all of the NAs from our surveys data frame. So I'm going to do that with the function filter, and then the next function, complete cases, that we have talked about before. And so if I filter out all of I only want the complete cases in our portal data joined CSV, I can say filter and then complete cases, and inside those parentheses, just put a period, because remember, the period indicates I want you to fill in this space with the original data frame that we started with. So what happens is if I run this line where I read in our surveys, and then in the next pipe, I filter only the complete cases, we start with our surveys data frame that's now 30,676 observations, which means it's omitted some of those with NAs. It just makes our life a little easier for plotting. Okay, so we have our data read in, and now let's talk about ggplot. So ggplot functions a little differently than functions that we have gone over before. And one of the big turns in this class is now where we're dealing with multiple functions nested within each other, and functions having multiple arguments. And ggplot has all of these things, so it takes a little while to get used to, but there is a logic of how ggplot works, and it just takes sort of some practice and repetition to get used to all the different arguments. But so how ggplot works is you generally open up a ggplot function with the function ggplot, and then it has three main pieces. And this is the data argument. So data equals, and then you'll specify the data frame that you're using. The next major argument is the mapping argument. And so within that ggplot function, you'll call mapping equals. And then when you are mapping, you will always call on this AES function. So mapping equals AES. And what this means is you are mapping these aesthetic components into a ggplot. And we'll kind of start with what these aesthetic components mean. But normally you can think of it as all of the pieces that you want in your plot. So this is your X variable, your Y variable, and then a few other things like colors, fills, shapes, sizes. So sort of the whole aesthetics of the plot. And then you close out the ggplot function, but then use a plus sign to layer on this idea of a geometric function, or we'll just call them geoms often. And all of these geometric functions start with the word geom, so GEOM underscore, and then there is a whole suite of different geoms that you can layer onto ggplots. And the geoms that we'll go over today are geom underscore point for scatter plots, geom underscore box plot for box plots, and I think Tyler will get into geom underscore line for trend lines. So let's sort of walk through what this means. And one nice thing about ggplot is that you can think of it as layering on different elements of your plot. So you will always sort of start with a base, and then you can use plus signs to kind of keep filling in all the different layers that you may want in your plot. So let's see what it looks like. So we'll start with the function ggplot, open parentheses, and let's first just start by specifying this first argument, which is data. So data equals, and the data we're going to be using is surveys. So if I just run this line of code, the plots box, if you're in RStudio, automatically opens up and populates with just a gray box. So this is giving us a good idea of where ggplot starts, which is that ggplot starts with just sort of this blank canvas. I know, and what you've told this function is, here's the data I want you to plot, but you haven't given it any other instructions. And so we can layer on these instructions, and we'll do this iteratively just to demonstrate what each of these pieces does. So just specifying data, gives you a blank canvas. But if you add on to this, so we start with ggplot, open parentheses, data equals surveys, and then we specify this second piece of our ggplot, which is these mapping aesthetics. So we can do mapping equals AES, open parentheses. And if you're in RStudio, you'll see it sort of prompts you with X, comma, Y, and then the dreaded ... But generally, the most basic mapping aesthetics you will need for a ggplot, depending on the kind of plot you'll be doing, is an X and a Y to define your two axes. So we're going to start with a geom point for a scatter plot. So we're going to want to be using two continuous variables, which are just good also to remind yourself of what kind of data you have and what kind of plots work for what data. So we're going to start with two continuous variables in our data set. In this case, we can do X equals weight, comma, Y equals hind foot length, because we know those are two measures that we have. And something that is good and bad about ggplot is because you have already specified that data equals surveys, just like in the tidyverse, you don't need to then retype data $weight. But the downside is that even though ggplot knows to look for this column name inside the data you've specified surveys, it doesn't auto-complete. So if you're starting to get used to that in some of the tidyverse world, you could always write the word surveys in front and use your $. If you wanted to be prompted with the different column names, this will actually make no difference, but you don't have to use the surveys $sign here. But so we've now added our mapping equals aesthetic X and Y arguments into our ggplot function. And if we run this line of code, we'll now see we no longer have just a blank canvas, but now we have a blank canvas with axes. And it says, okay, we have your blank canvas. We know that you want to map these X and Ys of weight and hind foot length, but we don't see the data on this blank canvas yet, because that is the job of the geom. So now we can add in the geom. So, and the geom is what gives shape to the data. So ggplot functions can be a little long-winded to write out often, and I'll show you a shortcut for that in a minute, but I think it's good to be typing this out every time to get in the habit. So ggplot parentheses, data equals surveys, comma, mapping equals AES, open parentheses, X equals weight, comma, Y equals hind foot length. And then we're going to go, so there'll be two parentheses. And so you can tab totally outside of this. So this bit is the ggplot function. And then here's an introduction of using a plus sign, which using the plus sign in this way, I think is pretty unique to ggplot. And sometimes I get confused of when to use a plus sign versus a pipe. But what this plus sign in ggplot means is I want to add on another layer. So this is where this layering concept now begins. So I can put a plus sign, and then I can continue to type after the plus, or I can space down, and ggplot knows to look for something after the plus sign, even in the next space. So I tend to space down after I put a plus sign just because it makes the code a little more readable. And this is where we start our geom underscore. And in RStudio, if you're looking at all the options it gives you, you can see there are many, many, many geoms. There are lots of shapes and special things we can do with our data. But we will start with just the geom point function and open up the parentheses here. And for now, we can just leave it empty. We're saying, I want to make these data into point data, but don't do anything else with them. And when I execute this line of code, we now have our blank canvas with our axes and with our data filling in our axes and our canvas as point data. So at the very best, this is sort of the basic plot that we can produce with two continuous variables with a geom point, which is a good place to start. But it, of course, can get a lot fancier as we build on. So I'll first want to note that one of the nice features of this layering element to ggplot is that you can save certain layers as objects and then add them on instead of retyping using this approach. So for instance, we can take this, what we'll call sort of our universal plot settings, which is this ggplot data and mapping arguments, and save it into an object before we start layering on geoms. So we might want to create an object called like base underscore plot. And then we can go ahead and rewrite what we have been writing. So ggplot, open parentheses, data equals surveys, comma, mapping equals AES, open parentheses, X equals weight, comma, Y equals hindfoot underscore length, two close parentheses. And we can run this line of code and create this new object called base underscore plot, which if we run this on its own, you can imagine will give us the same thing that happened when we ran just this line a few moments ago, which was this empty canvas. But now we can take this empty canvas and use this plus sign and add on our geoms this way. So if I do base plot, so our new object, base underscore plot, our new object, and then the plus sign, geom underscore point, open and close parentheses, then in theory, yeah, it populates our scatter plot onto this base plot. So that's a pretty nice feature when you're trying to play with new additions, but you don't want to keep retyping or copying and pasting or taking up many lines of code. Okay, so in addition to those basic X and Y aesthetics, there are also additional arguments that you can add to. We'll start with adding them into our geom that can help give our plots a little more character. So adding plot elements, and the most important, or at least maybe most common elements that I use to my plots are changing the transparency, changing the color and or the fill, which are similar color-based attributes. And transparency is, so some of these elements are well named very literally and others are not. So for transparency, we're going to specify something, an argument called alpha. And for color, we can specify a color named, an argument named color, which is nice. And you'll also come across this idea of wanting to outline a certain color, but maybe not. I messed this up. So color in some cases is a full color and in some cases an outline. Whereas in other cases, you'll see this idea of using an argument called fill, which depending on the different geoms you'll use will change where the color goes in that geom. So let's try this. So we can start with our base underscore plot object, which remember just houses these universal plotting settings. And we can add our geom underscore point. But then inside geom underscore point, we want to say something about what we want these points to look like. And so in our first case, we can try with this alpha argument. So I can type alpha equals, and then alpha, because it represents transparency, will be a numeric value that you assign between 0 and 1. I can never remember which is which. I think that 1 is not transparent at all and 0 is very transparent. So if we do 0.2, then you have, so our plot has now repopulated, looking almost the same, except what we have now is that the points in this plot are now very pale gray when they're standalone, which you can sort of see from the outliers. Whereas what this can help us do is see where points may be more or less concentrated that we may not have been able to see had we not added this alpha transparency argument to our plot. Another kind of addition is this idea of color. So we can do in a new line of code base underscore plot plus geom underscore point, and then color equals, and we'll talk more about color next week, but there are lots of different ways you can get different kinds of colors in ggplot. One of the features is that it actually has a lot of advanced and built-in color packages, but there are some colors that R and the ggplot recognizes just by name, and by name in quotation marks. So R will know that if I say color equals quotation mark blue, blue is a pretty standard enough color that R knows what that color is. If I tried to specify some color that in my mind existed, but maybe ggplot doesn't know, which I'm not sure, it might actually know aquamarine. It does. This is unfortunate. So now I'm gonna have to unthink of colors, but let's see. Anyways, I don't know any non-colors, but we'll get with that. There are some colors that R will not recognize. But so these sorts of additional plot elements that we're adding, alpha, color, do not need to be mutually exclusive. So you can put them both in the same geom argument. So you can do base plot plus geom underscore point, and you can do alpha equals a certain value. So let's say 0.5, comma, and then color equals red in quotation marks. And now we have red points that you may be able to see in some places are more transparent than when they're more highly concentrated. Okay, but more often than not, we don't want to just add transparency or just add a color for the sake of it. We want to associate a color with a particular variable in our data. And this is sort of a reminder of last week when we talked about pivoting. And I know we're still wrapping our heads around why pivoting is important. But for me, the importance of getting the data structure correct becomes really relevant when you start plotting. Because what happens is you'll realize you only have so many variables or columns that you get when you're plotting. You get an X, you get a Y, and then really you maybe get one or two more columns that you can use to communicate something about your data. And this is why plotting really likes long data, because what that does is it takes as much data as possible into fewer, longer columns. And so, for instance, if I wanted to color by a certain column, but measurements of something, so let's say I want to color by species, which we'll do in a moment, but let's say instead of having a species column, you had a column for species 1, yes or no, a column for species 2, yes or no. That would be a wide data format that isn't really well suited for plotting, because you want to be able to identify all characteristics that you want to be able to plot in one column quite often. But so let's color by we don't know, I often color by something categorical. Sometimes you can shade and color by something that's continuous, but let's color by a categorical variable in our data, and we'll do that with species ID, which is not the best practice for color coding, just because there are many species and oftentimes it can become unreadable, but just for the sake of learning. And we'll type this out in long form again, since, just so we can get in the practice. So we'll start with our ggplot function. We'll specify our data equals surveys, comma, mapping equals AES, open function x equals weight, comma, y equals hind foot length. And then I'll note now that there are multiple places where you can add aesthetics into a ggplot. And this also just kind of takes patience and practice, but you can specify, especially these additional arguments like color or like alpha transparency, you can specify them in sort of these global data options, or you can specify them in the geom, and where you specify them will have implications for, you know, which parts of the plot are sort of listening to that specific aesthetic mapping, which we'll sort of cue you into later when this becomes relevant. But for now, I am going to add a new aesthetic layer just to my geom point. So we've completed our ggplot function aspect. We're going to use our plus sign, and then we'll stick with our geom point. And inside, so where I had previously specified, say, color equals blue, that worked not as an aesthetic argument because blue has nothing to do with our data. You don't need to know anything about the data in order to create this specific aesthetic mapping of blue. But if we want to specify color equals and then a variable in our data, we need to nest this inside this idea of aesthetic mapping again. So I'll sort of show you a way it doesn't work, and then I'll show you the way it does work. So we had just learned that inside geom underscore point, inside the parentheses, you could find an argument called color and say color equals, let's say we want to do species ID. But if I try to run this line of code, I get an error that says error in this layer of the geom point that says object species ID not found, because I haven't specified this. When I start specify this aesthetic mapping, ggplot knows to look inside the data for a column variable name. I'm not even sure what would happen if I even specified where I want it from. Yeah, and so, but even if I said color equals surveys $ species ID, I say, okay, I want you to go into surveys and get it. Then the next error I get is unknown color name NL, because what this is seeing is it says the first species I see is NL, and just like it had known what blue was and what, you know, red was, it's saying, do I know the color NL? No, I don't. And so the issue here is that inside geom point, we need to create another layer of this aesthetic mapping. So we'll have geom underscore point, open parentheses, mapping equals AES, open parentheses. And then we can specify color equals species ID. And you do or do not have to have the surveys $ in front of species ID. I tend not to. So now we've specified another mapping argument inside our geom point. And what this is going to do, instead of looking for a color called species ID or a color called NL, it's saying, oh, you want me to basically use the species ID column as another variable to assign a color by the unique groups that exist in this data frame. So when we run this line of code, the output is now, it's this aesthetic mapping change that is queued ggplot into saying, I have now randomly assigned, or in a gradient assigned colors to each of the unique species ID that existed in that column. And it will provide a legend on the plot, and it will color the different points based on those colors. And so this is sort of the key where I said, if you didn't have one column called species ID, but rather you had a column called BA and DM and DO, then you'd have to be able to pivot your data and able to get all this information into one column. And you have to remember what goes in and what goes outside of these aesthetic mapping arguments. Okay, what else are we working with here? Okay, I think that'll be it for our scatter plot stuff, and we'll work more with this and begin to play with it in class. But briefly, I'm just going to present some box plot stuff. And maybe I'll specify that this is now geom box plot. So we have been adding on this layer of geom point Now we are going to use the layer of geom box plot instead. And I like to think of box plots as using, generally most useful with categorical bicontinuous variables. So in this case, we can start with our same sequence of ggplot function, data equals surveys, mapping equals AES, open parentheses. And so in this case, our X is now going to be our categorical variable because we want each box plot to represent a different category. So X equals species ID, or species underscore ID rather. And Y is going to equal weight. So this is saying by species ID, I want to see a box plot showing the distribution of my weights. Excuse me. And then I'm going to add the plus sign outside of all of these parentheses and then do geom underscore box plot. And if I just leave this empty, what we get is along the x-axis, we have sort of a jumble of all of our species IDs. And later we'll talk about changing some of the more visual aspects of ggplot to make this a little more readable. But we have all of the different species IDs on the x-axis, and on the y-axis is the range of weights and box plots that show that distribution. I can maybe open that up a little bit more. And just like with geom underscore point, with geom underscore box plot, we can be adding different things, different colors, different alphas. So I'm going to use my base plot again to speed things up. So I can say base underscore plot. This object is still saved, although it won't work because I will say, because I now have the previous base plot has the X and Y arguments I specified for the scatter plot. And so that would not work for this box plot. But so if I now create a box plot 2 object, just so that we can speed up the rest of our code, we can rewrite our ggplot, data equals surveys, comma, mapping equals AES, parentheses, X equals species ID. So remember our category here, Y equals weight, and then 2 closed parentheses. And now I can build on my base plot. So I'll do base underscore plot 2 is the name of my new object. And I can do plus geom box plot, but now I can try to, let's say, change the color of what this would do is change just the color of the boxes themselves. So remember, I'm not specifying an aesthetic within this geom. And so I'm not trying to do something with the data. I'm just trying to change something about the color. Let's see if R knows what purple is. Yeah. But what's important here is that, so this concept of layering is that one thing we can do is not just layer on one geom, but we can layer on many geoms. So I've taken my base underscore plot 2 plus geom underscore box plot, color equals whatever color you want. And then I can add another plus sign, and I can actually add on another geom. So not all geoms are compatible. If you can experiment with that yourself and find that out very quickly, but some geoms are. And so one thing that folks might like to do is you say, I have a box plot that looks at the distribution of the weights, and that's helpful, but it would still be nice maybe to see each point individually. And so I can add on the geom point that we just previously used, and let's see what happens. And because these are categorical variables and you just have for each category sort of a distribution of weights, it's not the prettiest because you have a lot of overlap. We're all following that singular line that represents a particular species. But there are 2 ways. You'll notice there are lots of things you can do in ggplot, and this is just a quick taste. But let's say we want to do our base underscore plot 2 plus geom box plot as we just did. You can specify any aesthetics you want in there, but then do a plus sign, geom underscore point. Well, there are 2 ways of doing this. So one is that a slight alternative to geom point is actually to use something called geom underscore jitter. And what a jitter is it actually explains to you. in the summary of geom jitter, so I don't have to make it up, which is that the jitter geom is a convenient shortcut for geom underscore point position equals quotations jitter. So I was going to show you that, but this is the shortcut. Because many geoms within ggplot have this position argument, which kind of helps move things around. It helps move bar plots from being stacked to the side. But most of the position names are not really intuitive. They just take some getting used to and some Googling. So this is ggplot quickly becomes one of the easiest Google go-tos, I feel like, in all of the R world. But so geom underscore jitter is the shortcut for a jittered geom point. And if we, what happens is if we jitter that geom point, what it means is that it just sort of clearly jitters it and like moves these points, that spreads them out a little bit so they don't all look so concentrated on a certain categorical line. And as this stands, this is also incredibly unhelpful because there's so many points that they actually shadow the boxes. So this might be a point where inside this geom underscore jitter function, you might want to specify a low alpha so that maybe if you make them really transparent, they fade, these points fade behind the box plots. Still not great, but you know, this is part of the experimentation with ggplot, which can be endless. And then of course we can layer in also multiple colors here. So we might want to, for some reason, even though we already have this categorical separation along the x-axis, you might want to say, but I also want to color these by the species ID as well to make it a little more visually easy. And so remember, if you want to color, not just by a color, but by a variable, we're going to call upon our mapping argument. And so within geom underscore jitter, we've already specified an argument alpha equals 0.2. Then we can comma and do mapping equals aesthetic, what is it? No, species ID, species underscore ID. And just like previously, when we had done this mapping aesthetic in our geom point, well, I actually said, so what I had written was mapping equals AES species ID, but I didn't say what about species ID I wanted ggplot to do, so it did nothing. I forgot to specify the color argument inside that aesthetic. And whenever this populates, now it is taken, in addition to having these labels on the x-axis, we have colored by points. And note that the colors are now on the points, but not on the outline. This is not really populating well, not on the outline of the box plot, because we specified the aesthetic in the geom underscore jitter, not in the geom underscore box plot. And so this is sort of the last thing I'll leave you with is where specifying aesthetic matters. And so had I specified color equals species ID in the universal level of my base plot, then both the points and the box plots would have been colored. But because I specified it within the geom underscore jitter, that color exists only in the geometric jitter, not in the box plot. And so I will leave us here and we'll practice this in class.